Assalamualaikum everyone. In this video we will do some of the exam style questions related to alkanes that I have compiled from some of the latest past papers. So let's start the question. Question number 1 is an incomplete equation for the reaction of propane with chlorine is shown. So basically this is a substitution reaction in which hydrogen atom of propane is substituted with the chlorine atom. And the replaced hydrogen atom is then combined with the chlorine atom to form hydrogen chloride gas as a byproduct. Now the question is, a student writes 3 statements about this reaction. The first statement is the activation energy for this reaction is provided by the ultraviolet light. Yes, ultraviolet light is the basic and the necessary condition for the reaction to take place as it helps in the breaking of bond between the chlorine atoms to start the reaction. So statement 1 is right. Second statement is C3H7Cl has 2 different structural formulae. Okay, we will check this. In the displayed structure shown, I will first number the carbon atoms. In this structure, chlorine atom is present at carbon number 1. So its name will be 1-chloropropane. The second option is that chlorine atom can be present at carbon number 2. 1, 2 and 3. Rest of the bonds will be made with the hydrogen atoms. So the second structure will be 2-chloropropane. So this means that the second statement is also correct, as there are 2 structures with the formula C3H7Cl, that is 1-chloropropane and 2-chloropropane. Third statement is X is an acidic gas. Okay, hydrogen chloride gas is formed as when it dissolves in water it gives hydrogen ions. This means that it is an acidic gas. So the question is, which statements are correct? All of the 3 statements 1, 2 and 3 are correct. So option A will be the right answer. Next question is, a chlorine atom can replace a hydrogen atom in a molecule of butane. The structural formula of butane is given to form chlorobutane. Okay, how many different structural isomers of chlorobutane can be formed? Okay, first of all we will number the carbon atoms 1, 2, 3 and 4. Now the first possibility is that the chlorine atom which is going to replace the hydrogen atom is present at carbon number 1. 1, 2, 3 and 4. Its name will be 1-chlorobutane. And the second possibility is that the chlorine atom is present at carbon number 2. Its name will be 2-chlorobutane. So there are 2 structural isomers of chlorobutane. So B is the right answer. Third question is, which equation shows the reaction of ethane with chlorine in the presence of UV light? This is again the question related to the substitution reaction. The question is about the reaction of ethane with chlorine. So we will write down the equation. The displayed structures are shown. I will simply construct the equation with the molecular formula. C2H6 is the molecular formula for ethane. It will react with chlorine molecule to form. Now the chlorine atom will substitute the hydrogen atom of ethane, and the resultant organic compound will be C2H5Cl plus the substituted hydrogen atom will combine with the chlorine atom to form hydrogen chloride gas. So in all 4 options, which gives a similar equation to the equation that we have constructed, shown is option C is the right answer. C2H6 plus chlorine molecule makes C2H5Cl chloroethane with hydrogen chloride gas. Next question, question number 4 is, which statement about the ethane is correct? So, option A is, each ethane molecule contains exactly 7 bonds, all of which are single covalent bonds. Okay, let's draw the displayed structure of ethane and then we will count the number of bonds present. Now we will count the number of bonds. 1, 2, 3, 4, 5, 6 and the bond between two carbon atoms 7. So there are 7 single covalent bonds are present in each ethane molecule. This is the right answer. Option A is the right answer. We will check the other options as well. Next option is, ethane is a member of homologous series of alkanes. Yes, this is right. A family of unsaturated hydrocarbons. Now this is wrong. Alkanes are saturated hydrocarbons. Option C is, the equation for the complete combustion of ethane is C2H6 plus 3 molecules of oxygen to form 2 molecules of carbon dioxide with 3 molecules of water. Now in this equation, carbon and hydrogen atoms are balanced, but oxygen atoms are not balanced. There are 6 oxygen atoms on the reactant side and 2 into 2 makes 4 plus 3. 7 oxygen atoms on the product side. So this equation is not balanced. Last and the D option is, when a molecule of ethane reacts with chlorine, one hydrogen atom is replaced by a chlorine molecule. No, this is not right. One hydrogen atom is replaced by a chlorine atom, not molecule. So A is the right answer. Next question is, which compound has the most single bonds in one molecule? So the structural formula are given in the options. We will draw the displayed structure given in the each option. Now we will count the number of bonds present in them. 1, 2, 3, 4, 5, 6 and 7. 7 single bonds are present in option A. Now in option B, 1, 2, 3, 4, 5, 6, 7 and 8. 8 single bonds are present in option B. In C option, there are 1, 2, 3, 4, 5 and 6. 6 single bonds are present and 1 double bond is present. In the last D option, this is not the correct structure, as in the structure the central carbon has not 4 complete covalent bonds. It has only 3 covalent bonds. So this is the wrong option. Now option B, ethanol has the highest number of single covalent bonds. So this is the right answer. Next question is, octane is an alkane with 8 carbon atoms per molecule. What is the molecular formula of octane and how does its boiling point compare with that of butane? Okay, first we will derive the molecular formula of octane from the general formula of alkanes, that is CnH2n plus 2. So n here is 8, C8 H will be 2 into 8 makes 16, 16 plus 2 is 18. So C8H18 will be the molecular formula, and when we compare the boiling point of octane with that of butane, we should know that with the alkanes with the higher number of carbon atoms have strong forces of attraction between their molecules, so they have higher melting and boiling points. This means that octane with the 8 carbon atoms has higher boiling point as compared to the butane, which has 4 carbon atoms. So which option will be correct? C8H18. A and B becomes the wrong options as 16 hydrogen atoms are present instead of 18. From C and D, C8H18 will be the molecular formula of octane, and the boiling point of octane is higher than butane. So D option is the right one. Next, question number 7 is, which compound is an alkane? So in all 4 options there are 4 carbon atoms present. So we will derive the formula of an alkane with 4 carbon atoms by putting the value of carbon atoms in the general formula. It will be derived as C4H will be 2 into 4 makes 8, 8 plus 2 is 10. So now we will check the options which has the molecular formula C4H10. So we will write the molecular formula for each option. For option A, there are 4 carbon atoms and hydrogens are 2, 3. 3 plus 2 makes 5 and 5 plus 3 is 8. C4H8. This is not the right option. Now check the option B. C4 hydrogens will be 3 plus 1 4, 4 plus 3 7, 7 plus 3 is 10. So C4H10. B is the right answer. Now next question is, 2 statements are given. Statement 1 is the percentage of carbon by mass is greater in methane than in butane. So we will check the percentage of carbon in both methane and butane. In methane the percentage comes out to be 75% and in butane 82.7% of carbon is present. So this is not the right statement. Next statement is, butane is one of the 2 isomers with the molecular formula C4H10. Yes, this is the right statement, as for 4 carbon atom, but is used as the prefix, as it is an alkane, so the names end with an alkane. So butane is one of the isomers with the molecular formula C4H10. Option C is the right answer. Statement 2 is only correct. Now we will solve some of the structured questions that comes in paper 2. First question is, the alkanes are homologous series of hydrocarbons. Give the general formula for the alkanes. So answer will be CnH2n plus 2. Next part is, the structure of one isomer of an alkane is shown. Okay, name this alkane. To name this alkane, we will number the carbon atoms 1, 2, 3 and 4. For 4 carbon atom, but is used as the prefix and the name of an alkane ends with ane. So butane is the name of the isomer shown. Next is, draw the structure of different isomer of this alkane. Show all of the atoms and all of the bonds. This means we have to draw the displayed formula of this isomer. The first isomer shown is the straight chain isomer. Now we will draw a branched chain isomer. We will take 3 carbon atoms in the main chain and 1 carbon atom will be taken as a branch. Now we will draw the remaining bonds of carbon atoms with the hydrogens. There are 4 carbon atoms and each carbon atoms makes 4 bonds. So be very careful while drawing the bonds with the hydrogen atom. So this is the structure of another isomer with 4 carbon atoms and it is a branched chain isomer. Okay. Next part is, larger alkane molecules are cracked to form smaller alkane molecules. State the meaning of term cracking. Okay, what is meant by term cracking? It is a process in which longer chain alkanes are broken down into smaller alkanes and alkenes in the absence of air. Next question is, explain the importance of cracking larger alkanes into smaller alkanes. So you may write down any importance or any use of the cracking. I will write it will form alkenes which are used as raw materials for the manufacturing of plastics. Next question is, state two conditions needed for cracking. Okay, the first condition is catalyst, that is aluminium oxide and silicon 4 oxide. Next is the temperature, that is between 400 to 600 degree Celsius. Next question is, alkanes are homologous series of saturated hydrocarbons. Draw structures of two different alkanes with the molecular formula C4H10. Show all the atoms and all the bonds in each structure. This means we have to draw the displayed structures with the molecular formula C4H10. So the first structure will be a straight chain structure with 4 carbon atoms, and rest of the bonds will be made with hydrogen atoms. Okay, the second structure will be the branched chain structure, in which 3 carbon atoms will be present in the main chain and a branched at middle carbon is present. The rest of the bonds will be made with the hydrogen atoms. So these are two different alkanes or two different structure of alkanes with the same molecular formula C4H10. State using general formula of alkanes the molecular formula of an alkane which has only 12 carbon atom in its molecule. So by putting the value of 12 carbon atoms in the general formula, that is CnH2n plus 2, the formula of an alkane will be C12 and hydrogens will be 2 into 12 makes 24, 24 plus 2 is 26. So C12H26 is the answer. Next question is, construct the balanced chemical equation for the complete combustion of an alkane with 12 carbon atoms. Okay, so we will construct the equation C12H26 plus oxygen, as this is an example of complete combustion. So carbon dioxide gas is produced with the water vapors. Now we will balance this equation. There are 12 carbon atoms on the reactant side, so there must be 12 carbon atoms on the product side as well. Then hydrogen atoms, there are 26 hydrogen atoms on the reactant side, there must be 26 hydrogen atoms on the product side. So we will write 13 with the water. Now we will look for the oxygen atoms on the product side. Now there are 12 into 2 makes 24 plus 13 oxygen atoms from water. There are total 37 oxygen atoms on the product side. In order to balance it, I will write 37 with the oxygen molecule on the reactant side and multiply rest of the equation with the 2. Now the final chemical equation will be 2C12H26 plus 37 oxygen molecules combines to form 24 carbon dioxide molecules plus 26 molecules of water vapors. This is the balanced equation for the complete combustion of alkane with 12 carbon atoms. Next, part C is butane C4H10 reacts with chlorine to give several products. Name the type of the reaction above. So, as alkane in this reaction is reacting with the halogen and halogen atom, they are going to substitute the hydrogen atoms in the butane. So, this is an example of substitution reaction. Substitution reaction. Next part is state the condition needed for this substitution reaction. UV light, ultraviolet light is required for the substitution reaction to take place as it is a photochemical reaction. Next question is construct the balanced chemical equation for the reaction between butane and 2 moles of chlorine. Okay. Now we will construct the equation. Butane is C4H10 plus it is mentioned that 2 moles of chlorine are used. So how the products will be formed? To make the products, first we will see that how many chlorine atoms are present in total. So there are total 4 chlorine atoms, out of which 2 will go in the main product and 2 will go in the byproduct. So this means that main product is the organic product, which is formed by substituting the hydrogen atoms of an alkane with the chlorine atoms. So C4, as 2 chlorine atoms are going to substitute it, so there will be 8 hydrogen atoms. C4H8, Cl2 is the organic product, and the 2 hydrogen atoms which are substituted, they react with 2 chlorine atoms to form 2 molecules of hydrogen chloride gas. So this is the balanced chemical equation for the reaction between butane with 2 moles of chlorine. That's all about the structured questions of alkanes. So I hope that this video will not only help you to reinforce your learning and test your knowledge, but also helps you to tackle the question in exam. So if you find this useful and easy to use, don't forget to like, comment and subscribe for more chemistry content. See you in the next video. Allah Hafiz.